Alright, so I think I'm recording. So again, we've been given these equations, these relations between x and y, and we're asked to find the domain and range and to express our answers using interval notation. Now, to find the domain given an equation, we always start out the same way, that the domain is the set of all real numbers, excluding any values of x that cause division by 0, and also excluding any values that cause us to take a square root or even root of a negative number. Well, I don't have any variables in a denominator for this problem, so I don't have to worry about that. But I do have a variable underneath the square root. And this problem is going to be a little more challenging than most inequalities because x is being squared. It's just not x minus 36, it's x squared minus 36. So it is a challenging problem if you have x minus 36 for that to be 0 or positive. Because when we have these quadratic, we always want the 0 on one side, and then on the left-hand side, we always want to write it in factored form. So you would not add 36 and try to take the square root of both sides, because with inequalities, you really can't do that. You're not going to get the right answer doing that. So x squared minus 36 factors to x plus 6 times x minus 6. And that is greater than or equal to 0. Well, they have a technique that when you have a quadratic, that you first you factor it, and then you look at what they call the critical points. You focus your attention not on greater than or equal to, but you focus your attention for just a moment on if this was equal to 0. And if this were equal to 0, negative 6 and positive 6 would be solutions. But that's not what we have. We also want all the values that make this product that is bigger than or equal to 0. So because of this inequality, what this negative 6 and positive 6 does for us, it cuts the number line into 3 regions. Numbers that are to the left of negative 6, we're just going to call that region A. Numbers that are between negative 6 and positive 6, I'll call that region B. So then, of course, values that are bigger than 6, we'll call this region C. And what we do is we pick test points. We pick numbers that are easy to do arithmetic on. So left of negative 6, I'm just going to pick a test point of negative 7. And to the right of positive 6, I'm going to pick positive 7. Now, a nice test point between a negative number and a positive number is 0. Okay, so you might be thinking test point, well, what is he going to test? I'm going to test to see if my inequality is a true or false statement. X squared minus 36. If x were allowed to equal negative 7, then I would have, instead of x squared, I would have negative 7 squared. And if I have negative 7 squared minus 36, is this a true or false statement that negative 7 squared minus 36 is bigger than or equal to 0? Well, negative 7 squared is 49. And 49 minus 36, 13. And that, yes, that's bigger than or equal to 0. That's a true statement. So since it's true for this test point, it's going to be true for all of the points in my region A. So that means that all of those points in region A are going to be in my domain. Now, let's test it for 0. And you can see maybe already that we're going to have a problem. We've got 0 squared minus 36. And this inequality is saying that that's going to be a number that's greater than or equal to 0. But negative 36 is not greater than or equal to 0. That's a false statement. This test point did not make this inequality a true statement, so I'm not going to pick any of the test points that are in region B. If I pick any point in region C, 7, 8, 9, anything bigger than 6, if I square it and then subtract 36, this is going to be a true statement. We've already seen it. 49 minus 36 was 13. 13 is bigger than or equal to 0. So fortunately for us, if it's true for one number, it's true for all of them. It's true for all of region C and all of these points. So all of these points are in my domain. So I need to describe what's shaded here and call that my domain. So my domain is from negative infinity to negative 6, including negative 6, or from positive 6 to infinity. And that's my answer for my domain. So anytime that you have a quadratic, x squared, that's underneath a radical, you're going to have to have it be greater than or equal to 0, or if it's in a denominator, strictly greater than 0. You need 0 on one side. You need to find your boundary points, negative 6 and positive 6, and then that divides your number line into these different regions. We'll see some other similar examples, similar problems to this. The first time you see this, you're not going to be an expert, but what's common to all these problems, when you have x squared, you'll be able to factor it, you'll be able to determine these critical points, you'll be able to cut up the number line into 3 regions, pick test points from each region, plug it in, and answer true or false to that original inequality. Alright, so what we need now to find the range is a graph of this. So I've already keyed this into Desmos, I think. If not, I can show you how to key it in. Alright, so there's our Edpuzzle. Alright, so see here on problem number 5, I just let the index be the problem number so I could quickly find it. So when I highlight this, I don't see it here, so I'm going to have to zoom out. There it is up there. Okay. So let's take a picture of this. Let's go and take a look at this. Now, we know that this is going off the graph, and we saw that it was going up forever on both sides. You know, if I zoom out, you can see that. You can see it's going up here to the left, and it's going up here to the right. And as I zoom out, that's just becoming more apparent. Alright, so as far as the range goes, remember, if you're in the range, I don't have to list the elements more than once. So it really looks like, because of the symmetry of this problem, I can focus on all the y values over here because those y values are repeated on the left-hand side. So let's start with the coordinates of this endpoint right here. It looks to be a 6 is the x-coordinate, but I'm interested in the range, which is the y values. So if I go up here 5, 6, 7, 8, this point is the point 6, 8. But like I say, I'm interested in the y-coordinates, and not only the y-coordinate for this point, but the y-coordinate for every point that's on this graph. Well, there's infinitely many of them. This is going on forever. It's going up. So all of these y values are above 8. They're bigger than 8. So my minimum y value is 8. And that's even true over here. Remember, this was negative 6, 8. But here it's 8, and all these points are above 8. They're just repeated over here. So my range is from 8 to infinity, including 8, so I needed a bracket there. Well, I hope that helps, and I'll talk to you later.